Hi students, welcome in chemistry classes. I am Priyanka Jain and today here we are with another important name reaction mechanism, that is Pinacol pinacolone rearrangement, and one more SemiPinacol rearrangement. Both of these reactions we will see in this video, okay? This is very much important for CSIR NET, GAT, IIT JAM, all exams. Several times questions are asked, but questions are not so simple, okay? So you should know all the basics, okay? So in this lecture we will see all the type of examples which can be asked in the next exam, okay? So if you want to see all examples, watch the video till end, okay? So let's start. First of all, understand what is Pinacol pinacolone rearrangement. Actually, it is the rearrangement of 1,2 diols to aldehyde or ketones in the presence of an acid. It means if acid is present and you have given 1,2 diol, then it will convert to aldehyde or ketone. And why this reaction is named as Pinacol pinacolone rearrangement? Because the first 1,2 diol that was taken is known as Pinacol. See it. This is our basic diol, 1,2 diol, and this is named Pinacol. And when it was treated with H2SO4 or acid, okay, it get converted to this type of compound. This compound was basically known as pinacolone. So this rearrangement is known as Pinacol pinacolone rearrangement. But you can do this reaction with any of the 1,2 diol and it can be converted to aldehyde or ketone. Okay. And one more rearrangement can be done with some other stereochemistry, that is known as SemiPinacol rearrangement. Whenever you have given a leaving group, okay. So firstly we are studying pinacolone rearrangement, then we will see what is SemiPinacol rearrangement, and all types of example we will see here. So firstly understand what is its mechanism. Mechanism is quite simple, okay. One thing you should remember here, that whenever you have given the acid catalyzed reaction, the first step will be the formation of carbocation. It means the protonation. Okay. Whenever you have given the H plus, okay, because H plus will be attacked by the lone pair of electrons and it get protonated. So firstly the carbocation will be formed. So see here what is happening. This is H plus. Okay. So here on the oxygen, you know, there is lone pair of electron. Okay, and this lone pair of electron can get attack on this proton. Okay, and which of the oxygen will get attacked? There are two OH groups. See here, this compound is quite symmetrical. This OH is surrounded by methyl groups and this OH is also surrounded by methyl groups. It means it is symmetrical. So any of the OH groups can be attacked. Suppose we are taking this one. Okay, so what will happen? We are getting OH2 plus. Okay, this we are getting. Now what will be the next step? Always when you are studying the mechanism, keep imagining what will be the next step. Okay, so here there is positive charge. This is oxygen. This will move like this. Okay, there will be removal of water. Okay, and we are getting a carbocation. Now when you have given the carbocation, what can be the next step? See here, whenever you have given a carbocation, then it will move toward the more stability side. It means it will go in that direction where it is getting more stability. So there may be alkyl shift, but you can see this is a this carbocation is a tertiary carbocation. Okay, so this is already stable. Now the question is why it will tends toward the more stability. Why? What is the reason behind it? The reason is this oxygen. See here, this oxygen is lone pair of electrons and it has a good tendency to stabilize the positive charge. So this positive charge wants to move toward this side. Okay, this wants to move here on this carbon, because on this carbon it will be more stable because there is a oxygen with lone pair of electrons that can stabilize this positive charge here. Okay, so what will be our next step? Our next step will be the migration of this methyl group. It means this methyl shift. Okay, as there are two same groups, this is methyl, so anyone can shift. Okay, and this will go like this. So in first step we are getting a carbocation like this. Okay, And then this is the lone pair of electron. Okay, so it will resonate in this manner. MEC double bond O plus H C Me Me Me. Alright, now you can understand what will be the next step. The removal of this proton. Okay, so this will move like this and we are getting MEC double bond O Me. Okay, so this is our ultimate product, a carbonyl compound. Okay, that we are getting. So this is the complete mechanism. Mechanism is quite simple. One thing you should remember, that which OH will protonate and which group will migrate. These are the two things that you should remember, and then you can do your answer very perfectly. Okay. So I am giving you examples. Firstly do yourself and then try with me. Okay. This is a cyclic dipole. Okay. Whenever you are taking a cyclic compound, always number it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, first step is the protonation. So, which of the OH group will get protonated? Anyone can be protonated because both are in the same environment. So, suppose I am imposing the H plus on this side. Okay. So, this will get converted to OH2 plus. Okay, here we are getting OH2 plus and this is OH. Now in the next step this OH2 plus will get removed. Okay, so I am removing it in this manner. Okay, so now I am getting here a positive charge. Alright, now see, this is 1, 2, this carbon atom. Now there will be the shift of alkyl group, so this carbon atom will shift on this side. Okay, it means this 2 number will get attached to the 6 number. So what we are getting, there will be ring expansion. This is 1 number, this is 2 number and this is 6 number. Okay, this is 6 number and at this 1 number there is this group. So move like this. Okay, then there will be the removal of proton. So we are getting double bond O, this compound. Okay, so this will be our ultimate product. Now the next thing is the what will be happen in case of unsymmetrical alcohols. If you have given 1, 2 diols that are unsymmetrical, then which OH group will get protonated? Always remember this thing remains on the stability of the carbocation formed. See here, this example. On protonation, which OH group will get protonated? Always remember the protonation depends upon the stability of carbocation. Okay, so we have to form that carbocation that is more stable. See, if we are forming the carbocation at this position, okay, at this position, if carbocation is formed, then it will get stabilized by this pH and this pH. Okay, but if we are forming carbocation at the next position, then this will not get so much stabilized. Okay, so we will have to protonate this OH group. Okay, so we are protonating this one. So we are getting pH, C, pH, C, H, CH3, OH. Okay, and here OH2 plus. Okay, then there will be the removal of this OH2 plus. Okay, so we are getting here a positive charge. Okay, now in the next step there will be the shift of alkyl group. Okay, but you can see there are two positions. One is this H and another is CH3, and we know that the migratory aptitude is H, then aryl group, then alkyl group. This is the order of migration. Okay, it means first of all, if hydrogen is present, then it will migrate. Then aryl group will migrate, then alkyl group. So hydrogen will migrate at this position. This is lone pair of electron that will move like this. So what we are getting? We are getting pH, C, pH, here H. Okay, and this C, CS3, double bond OH plus. In the next step, this H plus will get removed and we are getting double bond O. Okay, so this will be our ultimate product. Now see the next example. See here, we have given this compound. Okay, now again the same question, which OH group get protonated? One with more stable carbocation. So if we are protonating this OH group, then carbocation is formed at this position and it get stabilized by this CH3 and this H. Okay, so this will formed. Okay, so we have to make a carbocation at this position. Okay, I am not writing here all the steps, just try to understand. Okay, now this H or this H, anyone can migrate and this will move like this. So we are getting CH3, C, H, H, C, H, double bond O. This will be our product. Okay, I am writing here minus H plus. You can do all the steps yourself. Okay, I am writing it in short way. Now see the next example. Okay, we have given this compound and we are protonating it. So any of the OH can be protonated because both are in the same environment. So you can make the carbocation at any position, no matter. Now the next step is more important. You have to migrate any of the alkyl group. Which group will migrate? You have given two groups. One is this phenyl group and another is this group. Okay, and one thing here you should remember that the migrating group migrates with its pair of electron. It means the more nucleophilic group will migrate. Okay, because there is positive charge and the group with more electron density will migrate, and this group, obviously you can see this group has more electron density, so it will migrate at this position. So this is migrating here and this is moving like this. So we are getting, you are getting double bond O and pH. Okay, so this will be your product. Now see one more interesting example. See here, we have given this compound and this is treated with H plus. You can see this is also a diol. Then question is again same, which OH group you have to protonate. Okay, so you can see here this group. If we remove this OH, then we are getting the carbocation at this position. Okay, and this will get perfectly stabilized by this phenyl group and this phenyl group. Okay, so this OH we will have to protonate. Okay, so we are getting, this is OH and here this is pH. pH here firstly form OH2 plus, then remove this one. So you are getting here a positive charge. Then there should be a shift of alkyl group. Now which carbon atom will migrate? So this carbon atom will migrate here. Okay, and this bond will move like this. So number it. Firstly number it 1, 2, 3, 4, 5, and this is 6 number. Okay, so 1, 2 and 6. You have to make here in this manner. This will be 6 number. Okay, and at this 6 number there is phenyl group, phenyl group. Okay, and here will be double bond OH plus, and then in the next step you will have to remove this H plus, so that you are getting double bond O, pH and pH. Okay, so in this way you have to form the product. Now see one more rearrangement, that is SemiPinacol rearrangement. What is the difference between these two? See, try to understand both the things. SemiPinacol rearrangement is similar to Pinacol rearrangement, okay? But one thing is different, that here you have not given 1,2-diol. When you have not given 1,2-diol, but there is a leaving group. Leaving group means any of the halide group, maybe NH2 group, or it may be OTS group. Okay, such type of groups that may leave if this is present adjacent to OH group. Okay, if such types of group can be present and this group can be removed. Okay, this group is present and it can be removed by any reagent. Such type of groups is present and this can be removed by any reagent, then we are getting a carbocation. Okay, and then same type of reaction happens, so it is called semi-Pinacol rearrangement. See here, you can understand with the help of examples. Suppose you have given a reagent Ag plus. You know this Ag plus has a tendency to remove this Cl. So this can remove this Cl. Okay. So you are getting Me. Okay. And here you are getting a carbocation. Now the reaction can move in the same manner as you have seen previously. So there will be migration of methyl group. This bond will move like this and you are getting. Okay, it means you are getting the same product as you are getting in the Pinacol pinacolone rearrangement. Just you should have a leaving group and that can be removed to give a carbocation. Okay, next example, see here. You can see this is NH2 group that is present adjacent to this OH group. Okay, and now it is treated with NaNO2 plus HCl at 5 degrees centigrade. Now what will happen? Diazotization will happen. Okay, so this NH2 will get removed in the form of N2 and we are getting here a positive charge. I am writing here minus N2. Okay, now this methyl group will migrate. This lone pair will move like this and we are getting MEC double bond O C Me Me. In this manner you are getting your product. Okay, now I am giving you one example by which you can understand the basic difference between the two products that are formed by Pinacol rearrangement and semi-Pinacol rearrangement. See here. This is our basic primary compound that we are taking and it is treated with TSCl in the presence of pyridine. TSCl in the presence of pyridine will undergo tosylation. Okay, and the tosylation happens at the less hindered OH group. Okay, this OH group is more hindered. Okay, this is more hindered because it is surrounded by two R groups, and this OH group is less hindered. So we have to do the tosylation at this position. Okay, so we are getting here at this position R2 OTS. Okay, now this OTS in the presence of base or neutral medium. In You should remember here that in the case of semi-Pinacol rearrangement, we are not taking the acidic medium. Either the medium is basic or neutral. Okay, so now the same thing happens. This R group will migrate to this position. The push is provided from here. Okay, this group is going here. This lone pair of electron is going here. This is moving like this, and this group will migrate. So what we are getting? Here is one R group. This will be double bond O that you are getting ultimately by removal of proton. Okay, and here will be R1 and R2. So this is the product that you are getting by semi-Pinacol rearrangement. Okay, this is the product of semi-Pinacol rearrangement. Now see the next thing. If we are treating this compound with H plus, it means if we are doing the Pinacol pinacolone rearrangement, then what we are getting? Then in this case, the H plus will attack at this group, okay, at this position. So because in this case we have to find out more stable carbocation, okay. So this OH group will attack at this H plus, okay. So we are getting R1, R1 here, OH2 plus OH and R2. Now this OH2 plus will get removed, okay. So we are getting here a carbocation. Now this R group will migrate here, and this lone pair of electron will move like this, and again we are getting what we are getting? We are getting R1, R2, R1, and here at this position double bond OH. So this is the product of Pinacol pinacolone rearrangement. Now you can understand that in the semi-Pinacol rearrangement, the less hindered OH group is being attacked. Okay, but in Pinacol pinacolone rearrangement, more hindered OH group is being attacked because we have to get more stable carbocation. So two different types of products we are getting in Pinacol pinacolone rearrangement and semi-Pinacol rearrangement. This is the basic difference that you should know. So you should have to clearly see which reagent you have given, okay, and then you have to do the whole reaction. Okay, I think now the whole concept will be clear in your mind, and if you are liking this video, please comment me, and if you want more such type of videos, please share these videos with other students and subscribe the channel. Thank you.